So the supercontinent here, this is the planet see-through, and we've just mapped very um, loosely, roughly, the position of the supercontinent, starting with Valbara, which is about 2.8 billion years ago, that it sort of formed in this region, just maybe between Antarctica and South America, where it is today. And then it kind of loosened up and then quickly reconvened into Kendallin, approximately in the South Atlantic Ocean, straddled between Africa and South America. They're kind of a bit of a Y shape here. Australia is kind of down at the bottom there, and the Laurentia, or the core part of the United States, is kind of in the middle. And then, of course, there's about a 500 million year period of dispersal, and where all the continents moved in different directions there, and they all reconvened pretty much on the other side of the planet at the top end in the northern hemisphere, and created about 1.8 billion years ago thereafter Nuna, which is
Orange.
in orange and sitting in the northern Pacific area. It's just off between Japan and Hawaii. So some about 4,000 kilometres wide, maybe 13,000 kilometres long. So it was fairly long, kind of like a South America size continent, just sitting just over here. And then that loosened up. It didn't do a full break up and disperse, or loosened up and then reconvened quite quickly thereafter, about 1.2 billion years ago, in a much larger landmass here, Rodinia, that encompasses most of the Pacific. So it was surrounded by the Mirovia Ocean, even bigger supercontinent or super ocean around it. And this is during this period between Nuna and Rodinia that it was it's largely thought it to be a fairly inert time during planet Earth, known as the Boring Billion, but actually a lot happened during that time. That idea it was boring has quickly been dismantled by recent research there. And then that all pretty much dispersed by about 750 million years ago, and that's when, with the dispersal of Rodinia, it pumped huge amounts of bioessential minerals into the oceans, and then life boomed and sucked the carbon out of the atmosphere and other events, and we entered into the cryogenian big ice age for maybe about 150 million years, maybe less, where we sort of went from ice house, hot house, ice house, hot house, and pretty much really pushed life to its limit there. And that's at the end of it, we had the Ediacaran period, and then the Cambrian explosion, and that's when, during the full dispersal, then it started to come together once again. During maybe the Alice Springs orogeny, three separate events, and that was during the time when Pangaea was coming together. And Pangaea is enormous, this kind of big C-shaped continent. What you see up there is that's Laurentia and Eurasia, and then down here is the southern part of Pangaea that would have been made up of Australia, Antarctica, Africa, and South America. That sort of reached maximum packing or assembly around to 250 million years ago, and that's the time of the Permian, where a lot of volcanic activity occurred up in the Siberian traps, and then about 200 million years ago, that's when you started to break up, and about 180 million years ago, that's when you started getting some serious breaking up. Africa moved away, Laurentia moved away, Australia and Antarctica sort of hung out for about 100 million years. They were the last really to separate, and at about 80 million years ago, that's when Australia was kind of struggling to pull off Antarctica for about 50 million years. And about 30 million years, that's when Australia finally broke loose, taking Tasmania with it, and started flying up towards the equator there, with Antarctica sort of sitting down at the bottom there, with Australia sort of moving rapidly up here, and the projection is that it'll move, well, currently at about 7 centimeters per year in the northwest, but all these islands will start to create some friction, and then it'll start to swivel and basically move into China in that direction. That's what it is, and sort of creating Himalaya-like mountains around China, pretty much like India did about 80 million years ago, when it quickly detached and raced up there into Eurasia, creating the Himalayas. This is probably the future of Australia in a similar way.
Yeah, home
delivery of the natural resources of Australia.
Africa, Mediterranean Sea into Mediterranean mountains.
Oh, that's it. Yeah. So Africa pretty much there as well. I mean, Africa currently, this is going to sort of break apart there in very shortly, but in the meantime, Africa's moving up into Europe. You've got the Mediterranean Sea. I mean, this is pretty an important analogy there, because Australia had a kind of Mediterranean Sea-like environment, and it pushed together and created some really interesting strata there. But essentially got the Himalayas, not the Himalayas, the European Alps forming there. Like, in fact, the interesting stuff in the European Alps, you have African gneiss already being delivered up there, and that's been formed, and Africa will move in that direction as well. So
today we discovered that the Pilbara was once over where Mount Everest is today.
Exactly.
And so that brings us on to our next globe, doesn't it?
So that's where the supercontinents sort of going forward. But if we go back in time,
let's start at the present day.
Let's start at the present day, and let's now go back in time. This is Australia here as it is at the moment, and as I've just explained, Australia came from
let's line Australia up with the centre.
Yeah, that's it.
With this camera. Let's line it up. So we'll stick it.
Oh, okay.
There we
Australia.
go.
So I mean, we used a stencil here to sort of approximate the
Pilbara, Angola
position of Australia. So where have we got that? Oh yeah, so here it is. There. So we traced it out, and then we moved it down to the
50 million year intervals.
And 50 million year intervals going down. So here you've got 50 million years going down, and then 100 million years a little bit further down. It's pretty much about here, and then it is and around that position there, where it starts to do a bit of a dance out this way, and comes back down again to about 350 million years, and then it starts to head back up again in this direction. So we're about up here is about 500 million years. So it's gone down, done a bit of a loop, and then swung back this way, and is coming back over here. We've got 500 million years, and then
this one.
That one is
400.
400, and then we're going up to 500.
Yeah.
This is just very approximate. So it's actually tilted at this particular stage.
Our 500 is over Broome.
500, and then up to over here we've got
we get 600.
Yeah, so this is 650. This is the Yingan. The Perth is there in the Sea of Bengal, the Bay of Bengal, and just over here we've got 750.
750. Yeah, 750. So Yilgarn is. We're up in Iran.
So here, 650 million years ago, Pilbara was pretty much sitting over Mount Everest. That's quite interesting there as well.
Yeah.
And then, as you can see, it's starting to come over here, and then just north of the Caspian Sea, that's where the Pilbara was 700 million years ago, and then it starts to move across in a easterly direction, of course, and then we
so Yilgarn by 800
is back down here again. So what's happened in summary is that it's come down here, oscillated up here, swung to this side, come over there, started to tip on its side, and then it's going to sweep back across across here. It's 750 million years. That's or is that, what number is that?
450.
450. And
You got 850 there though.
850.
You got 8. That's your Gawler.
Yeah,
There's your 850
that's
on your
Gawler there.
Yilgarn.
And then it starts to come back, head up north now for
We've
its.
noticed as well, it sort of swaggers for a bit and then it does a leap and then
Yeah.
sort of staggers around for a little while, doesn't move too much, and then there's another leap. And it's doing this both in the northern hemisphere and in the southern hemisphere.
Yeah, that's it. Yeah. So, I mean, you got 900, that's Yilgarn over here. You've got it's steadily moving up here. But what actually starts to happen is it starts to turn, I think it's about upside down at about here now, doesn't it? Yeah.
Yeah, it's going, if we're going back in time, we're going starting to go counterclockwise.
That's it. So we're going counterclockwise, pretty much that it's sitting like this. And then by about 1,100 years, it's pretty much sitting up into the pole here, pointing down and upside down. And so at this point is where the cratons sort of came together and created the core of Australia, Central Australia as well. Prior to that, they were kind of loosely together in what is known as Proto-Australia. They hadn't actually amalgamated into one core. And then there's a lot of jostling around in this particular area. And then this is where it is a part of Nuna, where it's Proto-Australia, where the cratons are all hanging around together. And then during this time, at about 1.5 billion years ago, that's essentially when Nuna is breaking up. So we've been through Rodinia to Nuna, and then this period going into, actually this is Nuna. This is the period when it was together in Nuna, and then it is coming together into Nuna, and this period over here is the interim period between Nuna, going back into time, all the way over here to Kendalin. This is where Kendalin is. So 2 billion years ago, it was all in a full dispersal. And then coming down here, that's when it starts to reconvene, gather again, and come into Kendalin, and around this particular region here, about 2.5 billion years ago, 2.5 billion years ago. And then in the same sort of style of Nuna Rodinia, just before that, we have Valbara just down here. So Australia's journey down here about 2.8 billion years ago is sort of Valbara's here, sort of loosened up and became Kendalin. And then you had your 5 million year period.
Australia's getting smaller and smaller,
and it's smaller and smaller, and bits and pieces
and you can't
there.
Find it.
And so about here, that's where we've got the Pilbara here. Basically, the Ingan province is no longer is basically
the Jack Hills, the zircons are older, but we can't find them.
Yeah, that's it. And that's where the landmass around
zircons are what, 4.2, 4.4?
No, 4.404.
4.404, and we
that's
can't
it.
Find them.
But the landmass that is the oldest in Australia is the Pilbara, and so we've got a point just here in the Emberton Sea, where it is at the moment. And this is where the journey doesn't end for the Pilbara being the oldest continent. It essentially zips along here. And in this trajectory here, it's very the data becomes very slim, and it's difficult to interpret. But it comes back around here to 8, to 7, to 9, 3 billion years ago, and essentially we've got data up here to suggest that the Pilbara, in fact the marble bass chert is
what's that, 3,456?
yeah, that's it.
3,456 million.
Yeah.
Yeah.
And our journey kind of ends down here, over here. So we've got the Duffer Formation there, which is very close to the marble bar chert.
Even Australia's made in China.
Yeah, that's it.
3,470.
That's it. I've always said that.
I know.
Yeah. Yeah, so this incredible sort of journey around here with the, it's not very well constrained. The data, paleomagnetic data is pretty loose. The dates are that we've got here.
And the closer we get to the present, the
yeah.
more precise we get as you do.
Yeah.
It's sort of like
So
trying to
coming
remember
down
your
here,
life.
So this, if you wanted to sort of retrace the oldest continent or the oldest craton, it starts somewhere up here in China and comes around here.
It goes earlier than that. We just got to find
down,
it.
Yeah, it goes earlier than that. Got to find it. And then across here, down through past New Zealand, and then zipping along here through Walbara, then up through Kendalin, up through here, and then it zips across the North Pacific, and there's data trail that goes all the way over here where it becomes Nuna in the northwest Pacific here in this large region, and then of course Rodinia and a larger landmass, and then it comes down over here and sweeps down through Asia and comes all the way as far as pretty much it's done a circumnavigation. It's sort of past the point where it was emerged from the Earth's surface, past over here the Caspian Sea, and then back down across the islands and sweeping across here, and then down here, and does a little pendulum, and then back down up here and over there to where we are today, and then later over the next 70 million years it'll come back up here to China. So that journey there, if we add it all together, that journey around the world journey in a very roundabout way would be about 3.7 billion year journey from where it will be crashing in here in about 70 million years. So at about that's about 3.5 billion year journey from here all the way back around and doing those crazy loops back into China again. Here we go. Made in China, and we're coming back to its origins. So there you go. Interesting that is.
That's it. Yeah. Like the marsupials.
Very rambly. But
origin of marsupials is also.
Yeah. Okay.
China into North America, South America, Antarctica.
Yeah.
Australia arrives, drops off its kangaroos. Said, hey, we were made here anyway. So there you go.
Very rambling, but
it's the nature of it.
Yeah, that's it. Just putting it all together, actually. But that's incredible. That's
incredible. And
amazing.
It's amazing.
Yeah, that's amazing.
That's amazing.
It's amazing. It's amazing. Yeah. So down here, it goes down there, does a bit of a swing, and then comes up here,
and over, get a curry, and
here,
that was good.
Over there, and then go back here,
let's
and
try
then back over there.
a bit of sushi. Please. Up and
so
over.
If I was
like
to
a bit of a
like
Millennium Falcon.
The hand of sort of like this. So it goes down, up, down, up here, and then it does this, like this, and then it goes like that around here, and then goes up there upside down. Sits up there, comes down here, and goes across here. Across there and down here, and does a swivel across there, and then it does a swivel apparently there, comes up there, and then you've got the Pilbara, and then it comes over there, through here, and over there, and across Europe. This Pilbara comes around there, and emerged there.